the big Leslie 910 rotating speaker organ cabinet with a separate removable top rotating horn part here and the bass section down there. It's quite a impressive big beast, but it's an unusual design. Leslie started off with quite a simple design really, with the rotating horn and rotating baffle and the bass, 2 speeds generally, and a fairly simple circuit. And then over the years it got more and more complicated, and this one is particularly complicated, and I've got to service it because it's got some faults. Why is it complicated? Well, it contains something called a Tremelo Reverb circuit, which has a reverb unit. Here we can see a nice big long Hammond spring, which is pulsed in time with the rotating horn through these two side speakers here. So the sound of the reverb is not just a reverb, it goes on and off, and you can vary the depth as the horn rotates. It's in exact synchronization. So they made this complicated piece of equipment here, electronic circuit here, which is a capacitor with a shaft and a rotating part in the middle, which goes round and round and varies the capacitance. And it's driven off the same chord band here that turns the horn. It also turns this via this wheel. And there's lots of electronics inside. It's held on rubber and everything. The problem is, well, with this one, that it has a shaft that goes round here. It's like a plastic part that came out and held the wheel on, and it was all in one piece held on with this nut. Well, somehow or other, over the years, it's sheared off, which is pretty weird considering it has very little force applied to it, except just a bit from the belt. So it must have just aged. It's quite a small contact because you can actually see the contact area where it's sheared off. And considering it's not subject to anything except rough handling, it's obviously a design flaw. Now, how to fix this? Well, you can't take this apart. This capacitor unit is all screwed together as one piece with that coming through the middle. And we've actually got a service information here, and it says, it's got a picture here we can see, and for the serviceman it says, any problems involving the tremolo generator will require its removal. The circuit and variable capacitor assembly is fairly complex and field repairs may be rather difficult. Yeah, they're not joking. If that shears off, there's not much you can do about it. So, what to do? I don't know. I'm going to have a look at that. It may be possible to get a modern glue or a spacer and a longer screw that goes down inside. I'm going to have a look at that. Now the electronics itself, as you can see, is quite a sophisticated little board. It's got capacitors, lots of capacitors, transistors, all sorts of things. Why did they make something so complicated? Because it must have cost them some decent amount of money. Do you think anyone can notice this when they're playing live? I very much doubt it. It's just something that they've dreamt up. And also, that added a lot of money to put all this in, because look at all these connections and everything, lots of money spent. And then they saved a bit of money because down the bottom here we've got, let's just get this board down, this is the amplifier board, and inside here's the rotating baffle, with this chute that shoots the sound down from the bass speaker out through here, the bass speaker. But it's only one speed, it's just fast or off. So they saved a tiny little bit of money there. And also maybe they, I don't know why they've done that. Big speaker, massive volume here. Let's go back a bit for the bass speaker. I mean, I don't know why it has to be so big. Really, they could have made it a bit smaller, but maybe they just wanted to make the thing really impressive looking. As I said, the tremolo, the reverbs, dual springs you can see on the back, they're still attached, nothing's broken, and it's got quite a nice thing here which pulls it and presses the springs against like a foam or felt pad for when you're moving it around to stop the springs smacking about and perhaps eventually breaking or damaging the transducers. And this cord comes down, it's wrapped around a little thing down here. Looking inside, you've got an impressive power supply that operates the motors and provides all the power in here, which is loose at the moment. If I undone it, you've got the power section here, 3 amplifiers. The bass one's got a slightly bigger transformer, one for the horn and one for the side speakers, and then you've got this lot of electronics in here, or more electronics for driving the reverb and mixing the tremolo that comes in. So lots of more transistors, lots of things that go wrong. The original Leslie's had these, virtually all of the non-valve ones. These circuits are almost identical in all the models that they made. Whichever one you take apart, these seem to be the same. They just vary the capacitors and we just adjusted the input to affect the frequency response slightly. The tremolo one, the treble ones have a cutoff below about 800 Hertz, just so the bass doesn't go into them. And the bass one's supposed to have no treble going in, but I don't think that made any difference if we had treble going in or not. This is quite nice, this chute. It's like different design to earlier ones. Still fairly lightweight, so it will obviously spin up quite quick. The power transistors on this board here, 1, 2, 3 channels, lots of connectors that plug in. Everything gets a bit corroded over time, but still generally works. Now, one thing that doesn't work is the reverb, and I think it's because inside here there's a light dependent resistor and a bulb that shines on it, and as it shines it gives it the brightness varies, so it varies the volume, and the bulb's gone in that, so I've got to try and sort that out, otherwise we won't have any reverb, or I could fix it on full reverb. So two things. So the complicated part that they put into this, which is the reverb and the tremolo, are both the things that have gone wrong. So they've turned something that was fairly simple and worked fantastically well into something that is complicated and breaks down. I mean, we could do away with reverb and tremolo. I don't know if anyone would notice, but I'm going to try and fix it. Big cables running down from inside, so you can unplug these, wrap them up inside here, and there's a cover plate that with little nails that screws on, which is very useful with these little nails, so you don't lose the back, because most people tend to lose the back off the horn or take it off and they'll throw it away. But this one's quite good, so you put the cables in there, wrap them up in there, which is good. these massive heavy duty cables, 2 in there and 1 that goes off to the organ or whatever. So it's quite a substantial plate here that is screwed on, and to get this out I think I'm going to have to get the power supply out, I'm probably going to have to unscrew this as well and unscrew everything and unplug everything. On these amps, these high watt resistors I need checking. Sometimes they drift quite a long way out. These transistors here, heat sinked ones, 1, 2, 3, generally are okay. These amps are fairly reliable. It's just the power resistors you should have to check. People talk about the connections getting corroded and that, but generally the soldered connections I've found have been okay. Everything plugs in onto little pins. For instance, these things unplug like that. Even though it's crude, it does work, and they don't tend to give any trouble as long as they're pushed in. When you take all these connectors out, it might be an idea to make a note of the color codes, where they all go, so you don't get jumbled up with them. I haven't found too much problem with these power transistors. Weirdly, they are got push connections. You have to be careful that these, I haven't found any problem unless someone's been fiddling around with them. The power supply, yeah, sometimes additional capacitor can help, but the big capacitors I find generally survive after all these years. Speakers don't tend to blow out. So quite a lot of work. I don't know if a screw will go, how far a screw will go into that hole. Hopefully it can be done. It has a cover, metal cover. Everything is substantial on this. I mean, they never made anything small. They've got massive wing nuts, big rubber grommets, steel plates hold everything, covers. There's also another cover here that went over the top of this wheel. I'm not sure why, because it didn't have a bearing on the top. So I'm not quite sure why they bothered to put that in. It's not like someone's going to put their hand in and try and grab it. You can oil the bearings and everything up and down. So that's the Leslie 910, a complicated beast. Luckily the service information is available. Circuit diagram much more complicated than most Leslies, especially here. A whole bunch of electronics for the reverb, and there's that bunch of electronics up here for the tremolo generating thing, and they've shown the rotating capacitor around thing here. Wires, you have to follow them everywhere, and the input from the organ is just one signal comes in. You've got fast and slow switch in your actual audio. You've got mains, reverb, volume on pin 4. There's the light dependent resistor. That bulb was blown, so annoyingly got to work that out. Lots of helpful information, or well, a bit of help from the service manual. Without the circuit diagram it'd be impossible, but I'm not much help with this. They just say you can't really service it, and they're right, but we'll give it a go. Attempting to repair this disc that is broken off. The bit of plastic snapped off that holds the disc on. I found like a 4mm screw bolt, just fits in the hole. It's not very deep, it's probably about 4 millimeters of depth, but it's good enough to just tighten it up. So all I've got to do is work out whether I can put the collar on. Be careful when handling these rotating vanes, they mustn't touch the fixed vanes either, because that's the capacitance. If they touched on any of the 4 sides, it would short it out and it wouldn't work. Ready to repair this broken part on this tremolo generator. So I managed to get some 14 millimeter grub screws in the end, because I think that's the only way I'm going to do it. And it screws in down a little way, goes in about 4 millimeters before it hits the end. And the hole was the right size, it just went in really nicely. Now the spacer, I had to drill a hole out in that 4 millimeters to clear, and I can screw that. It goes on right down to the end. I could put some glue on it if necessary, but I don't think it. I don't. And because it's make sure it fits in the right place, because it's slightly broken off at an angle. And then we can fit the plate now back on, and it's going to be rotating now. And now still a bit of stud left out, so I'm going to put a nut on there, some 4 millimeter flange nut here, and I just got the length of this 14 mil just to make sure that when we put the top plate on, which isn't necessary really as far as I can tell, it doesn't hit underneath. There is a bit of clearance left when I put it on. I'm going to put the nut on. There's going to be a little bit of clearance. So I can use the washer if necessary, as well as the nut. As I said, I don't think I'm going to need any glue. I think this doesn't really have much side force on it from the belt. I think it's a felt washer or something, so a little bit of oil before I finish off. And I think that's going to work perfectly. I can put the cover back on it. I mean, this works at pretty high voltage, about 250 volts on that capacitor, so you've got to be careful that you don't bend it out of shape. Put the cover back and put it back in. The wheel secured in place. Now rotates nicely. Install back in, and with the belt on, you can see now that as you turn the horn turns, so does the belt on that side of that disc turn in synchronization. So that's good. A few screws and you can get this out. There's the front plate, held on 2 screws. The big power supply is pretty heavy, big power transformer there, and the plate here. Need to disconnect a few wires, including one for the lower motor. Make a note just of the red of these ones here when you're going to take them out. So, and any others on here, the colours of all these connectors that plug in here. So when you take it apart, you can disconnect one from the other. You can check over these capacitors and anything under here. Just have a look. We'll have a look around underneath. Just see if anything's burnt out. I generally find they're pretty good. You might just check the capacitors, that's all. And I'll just go over the amps. Most of this light is permanently wired, so if there's any faults with this, which hopefully there never will be, you're going to take it apart and do a bit of soldering. I've found that's not normally necessary. Checking out the components in the power supply, just make sure they're alright. I have noticed that these lovely big Malloy capacitors, they look really nice, and it's got a date code on it. It's made here in 1974, so we know this was made after 1974. And there's some other nice capacitors in here. You don't see this anymore. This is the Industrial Condenser Corporation Boilerset capacitor, long life. Lots of nice writing on it. And these ones also are long life by the same company. So it's important to make sure that these are okay. 5,000 microfarads, really nice and big. So we test the ESR, and 0.21 is good, nice and low, and the capacity over 7,000 microfarads. So these are connected basically in parallel with those. That's why it's such a big reading. Checking these other components to see what they're like. This one's it's a bit black, but I don't know whether that's just the glue they use to stick it down. These are the triacs or thyristors, whatever they used. Noticing that the cover here, it's got a burn mark just on this corner, because it presses up against this 130 ohm resistor. There's 4 of them. I have checked them with the meter, and they're all reading about 130, so they just run hot, that's all. Some nice heat sinks on the transistors. I've checked all the diodes. I've checked this 8 ohm resistor, that's looking good too. I think everything's alright. I've checked all the diodes. These capacitors should give enough smoothing. I don't think we need to worry anymore. These 3 are just for an additional power supply. Smoothing, they should give some very nice smoothing. Actually, it's shown on the power supply just here, a whole row of 3 just there. One diode that goes off 200 volts goes up to that tremolo circuit. Quite a voltage, and the rest, all these things here, I think they're going to be okay. No, it's as I thought. It's just they've used some glue to stick these down. You can't. There's some glue on the others as well if you look around the other side, and it's just turned a sort of a dark colour. Still a bit soft. It's not burning or anything. Before I can test the reverb circuit, there's a couple of things I've got to do. Looking at the circuit diagram, there's the spring reverb, and the signal comes into the transducer. It's got a lamp here, which is like an overload lamp as far as I can gather. It's normally pretty low resistance, and then as the signal increases, the current through it increases and the resistance goes up. It stops you overdriving transducer and making the spring sound horrible. Anyway, that's not so important, but the one that is important is this lamp and light dependent resistor, which affects the reverb either on, off, or medium power reverb. And it works that resistance goes from low to high depending on the lamp shining on it. And where does that go? Well, it's number 17. It goes over here and into a 20k pot, which adjusts the actual volume to the side speakers. So when that resistance is low, the whole of the signal passes here and it's amplified. When this goes high, high resistance, there's very little signal left on the 20k, because when that goes high, it'd be about a mega ohm or something, and so very little signal goes through. And when it's set to a medium sort of resistance, say 100k or something, there'd be a medium amount of reverb. Well, if this isn't working, then the reverb's not going to work. So I've got to check 2 things: 1, that the lamp still works, and 2, that the light dependent resistance works. How do you do that? On their parts list for this board, The lamp and LDR is down here. LDR AUP 66. So finally we know what the resistance is, an ORP 66, so we can find spec on that. Not that they make it anymore. As far as the lights go, nothing, but I did find somewhere on some piece of somewhere in the service manual that those lamps are 14.4 volts, which makes sense, and just standard in those days for bulbs for cars. Anyway, the cover was over that, this little shiny cover. It was glued on, but it came off and it had little clips on the bottom, and inside you see the bulb and the light dependent resistor, which is like a little squiggly bit on the top. The light shines on it and it's all reflected about inside to give it more sensitivity. How can we check if the bulb's working? Well, according to the circuit, it's got a 15 ohm resistor in series with it, which is right next to it. So I've clipped on the 15 ohm resistor and the bulb on one of the legs, and I connected up a power supply with the current limited so we don't blow the bulb, and turn it on and turn up the current a bit, and there it's glowing, so we know it's not blown. If I turn up the voltage, it goes very bright, and depending on the voltage being supplied, so we know the bulb's working. So now I've got to connect across this thing, the light dependent resistor, and see if the resistance bit varies up and down as well. Connected some clips across the light dependent resistor, and we got the bulb. I'm going to turn the light off. Over here I've got the resistance now that is being measured. As you can see, it's 218 kiloohms in the medium, well, light. I mean, if I cover it right over with my hand, it's gone to over a meg. So if I cover my hand over just a bit darker, see, 2 megs. So let's see what happens when I put the bulb on. And don't know if you can see the bulb there glowing, and up there you've got the resistance, 11k. I'll just turn up the brightness a little bit, 6k. I don't know if that is that might be fully on. I mean, it feeds into a 20k, so it's pretty good. I turn down the brightness and way up, and then turn the brightness back up. That doesn't need much to make it 11k, and that's only 6 volts to turn it fully on, and we need, and that's probably even with that on, it's going to be even fully on. Let's see if we can get about a half reading, which I said would be about 100k. 3.6 volts, it's about 100k. So that's, I'll write down those figures so that I know when I check the circuit, those are the sort of voltages I'm looking for. We want to go from off 3.6, and I said about 6 point something for fully on. Back together again. I'm going to test to see if it's actually going to work. I've connected up the cables, the amps. I've got a cable running into this control box, which I've modified because originally it was for 2 channels going in. Because this is only 1 channel, I've changed the wiring and put the reverb on this, so it's reverb on off, and a medium reverb which I'm going to set up on this potentiometer. It has a stereo input, but it's only mono now on this one. But forget the reverb at the moment. I want to test the operation of the motors, see fast and slow. So I'm going to turn it on. It's a bit of a buzzing when you turn it on initially. I think it's from the lower rotor trying to turn, and it shouldn't be. It's stopped now. So 2-speed on top, 1 on the bottom. So we go to fast speed, and that's working, and it's turning the synchronized tremolo. And the bottom one, which is also fast speed, is spinning good. Now we go to slow speed. Top one slow. The bottom one, the motor hasn't quite stopped, so it makes a bit of buzzing at the moment, and then it stops. Top one slow. Then we go to off. And then when I switch to slow again, you notice it doesn't start. That's because it's probably slipping on this rubber ring, and you can adjust the pressure of the shaft. That pressure's on that rubber ring as well, just by adjusting the screw and nut up and down here. So I'm gonna clean up that rubber ring and adjust that. You get a very slight hum from the motors when they're turning. But when you're playing music, so you won't hear it. So when you turn off, stops, and the bottom one is stationary on the slow speed anyway. The side nuts as an upper and lower one for it tilts the shaft. It tilts the shaft on the rubber ring, so you can undo that and lower it up and down and tighten it up till it's right. I think I got it right now, so I'll just show you. Slow speed, it picks up nicely now. Switched it off, stops, fast, off, slow, off, slow. Just got to sort out the bottom one now. What this why the motor inside is just not quite going off. I decided to disconnect the brake circuit from the lower drum, as I didn't like the buzzing sound it made when it was braking, which went on for about 10 to 15 seconds, which is part of the design of the circuit. I don't think it matters at all that the fact that when it goes from fast to off, that it carries on spinning. The difference is minimal in my opinion. So we've got the it off at the moment. I'll put it on to slow, which is the top one, goes round, and then the bottom one stationary, and then I go on to fast. You can see the bottom one picks up quite fast as it's meant to. The top one is spinning really quick. It's not too noisy. And then when I come off back to let me switch it back to off, you can see that it slows down under its own momentum. The top one stopped and the bottom one slows down. I don't think that's going to be a problem. I mean, I don't think it'd be a problem at all. At least you don't get that buzzing sound that you get from the brake circuit, where it's applying just a bit of power to the motor, makes it buzz like anything. So we've got slow on top and nothing at the bottom, then fast, picks up nice, and then I can go back to slow, and that slows down, and this one will slow down slowly. I'm going to leave it like that. I prefer it. It will stop. So now I'm going to work on the reverb circuit. A quick note about the brake circuit on the lower rotor in the 910 has only slow speed, and when you turn it off or turn to high speed, it has to stop the baffle going round, which takes a while to slow down. So they've got this little brake circuit here, and there's a bigger picture of it here. And what happens that when this is the on and off, normally this circuit's not there, so it's either on, these SCRs are on, or off, they're off. But for the brake purposes, it turns, when this opens, one of these goes off, and the other one is held on briefly by these capacitors, diode, resistors, which are a little charging circuit, and it takes a little while to charge these up. And while they're charging up, it holds this one on, which is half the power to the base motor. So instead of the base motor spinning freely, it has sort of half power, which sort of slows it down to a slower speed. Now this is, and then it finally slows down and stops because it doesn't have enough power on one of these. It makes a bit of a noise while it's slowing down, a bit of humming noise from the motor, and this is about 13 seconds delay. It actually talks about it in this here, about the brake circuit slowing down. I changed the capacitors to make it not stay on so long, so I didn't like the noise it made, and it doesn't matter if the rotor, the big baffle, does not stop going round. It slows down and stops on its own anyway. So just a few components that I changed. I changed the capacitors, basically 2 of them, to smaller values for anyone's interested in that. Now the next thing was the control circuit. Now originally this had a big foot pedal called the Deluxe preamp. The Deluxe Combo preamp, this is specific to the 910 because it had 4 switches, fast and slow, and also for the reverb on, off, and a medium volume of reverb. Now this isn't found on any other Leslie's, so this Deluxe Combo preamp was special to it, and the other foot pedals you find for Leslie's that look the same with 4 switches are not the same, because 2 of the switches are switching the channels, I believe, from channel 1 channel 2. It's not for reverb, although there's a circuit diagram how it all works and everything. So I wondered what to do about that, but I did have one of these, a thing called, a bit of shiny, try and get the shine off it, demo kit. Sorry, the light's reflecting on it. It's a Leslie demo kit. It's got, it was used for demonstrating the, it's got a 9-pin socket. The mains lead came in, and it had a stereo plug for left or right channel, or stationary rotating channels that are on a lot of Leslie's, and it was like to demonstrate that tremolo on, or slow, fast, on, off, and channel reverse switch, which just switched the organ or whatever stationary to rotary. I had one of these and I thought, well, the tremolo coil's fine. I'm sorry about all the circuit diagrams, but not that someone might be interested. And the reverb is controlled on pin 4, which is normally used pin 2 and pin 4 on a 9-pin connector, but normally used for 1 channel stationary or rotary. Now all I had to do is then utilize this pin 4 and put this little circuit in, which is the reverb is either earthed, open circuit, 3-position switch, or it had a Zener diode for medium speed. Well, I haven't got a Zener and they don't tell you which one it is, but anyone who's interested, the circuit diagram for the Zener diode controlled the lamp from a circuit here, and this little 2 transistors controlled, it was either full voltage, which is a 33 volts, comes 33 volts, and it goes off to the lamp through those connectors, and so the lamp's either on, off, and in the middle there was just a bit of voltage balanced out by the correct Zener. Well, I didn't have the Zener, but I thought I'd put a just a resistor, and you can do the same thing. You can balance it out, and it worked out actually better than the Zener, because inside I put a variable resistor, 10k. Worked out it should be about right, and it was the actual value about between 3 and 10 alters the volume from about low to medium high. I could actually put this 10k as a knob, and you could adjust the volume of the reverb. Anyway, I can preset now. And on the utilising these lever switches, I just rewired it. Didn't have to rewire the core, unluckily. Rewired, and there's the 9-pin plug with the mains and the audio, everything. It was a stereo plug for left and station rotary, so I had to just take the tip. Obviously, it's only one channel, and disconnect the stereo part. We still use the same plug, and put the pot in. I had to do a little bit of fiddling with the wiring to pin 4. So now I've got reverb. Reverb is off, fully on, and then medium, which is on the preset pot. So that worked out really well, because I could have just had reverb off and on, but I decided to do it properly and put the medium one in as well. So that is I'm going to just screw this to a board. So now I've got reverb control and speed control, and the input for any instrument. Of course, the instrument comes in here for those interested in electronics. It comes along here, and it comes into a 20k pot. So you need quite a good buffer or something to drive it. You can't just plug a guitar in. This is a preamp anyway. It's not loud enough. You've got to have an amplifier. Any foot pedal will have a buffered output. Organs, piano, electronic things have buffered output, so they easily drive this. Now, so there's a volume control on there. That's the overall volume, controls the whole volume for the amp, because this little few transistors here then send the signals off through these connectors to the 3 power amps, bass, treble, horn, and the side speakers. 3 amps. They're rated about 30 watts each, so it's quite loud. And each one has its own little volume control, 20k, 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 so you can turn them off, on, medium, fully up. So you can turn the whole sound up and down on this one, wherever it is there, and the individual ones. So 4 volume controls. And then the spring reverb, as I said, is the output of the spring reverb is controlled by a light dependent resistor, which is controlled by the switch on this thing. So that's how it all works. I've got it all working. The spring reverb's a nice long Hammond. If you put too much volume in, it can feed back. And that's one last thing I ought to look at. They had a lamp here, which I think controls the feedback. If the signal gets too loud, it cuts this, prevents the lamp comes on and lowers the signal. I've found that I haven't got the lamp on at the moment. I just put a 10 ohm resistor, and when you turn the volume up, it can start feeding back. So I'm going to fiddle around with a lamp on there. It's a 14.4 volt lamp, I believe I found out. It's about the last thing I've got to do, because I've done everything else, and it's just I'm going to fix this to a board just to cover the bottom up. I could put a lamp on it, because there is 28 volts plus available. I could put an LED, or it's got mains in it. I could fit a mains lamp. Could drill drill a hole and put a lamp. I may do that. That's just all extras. I'm just getting the thing working. So anyone interested in electronics, it's just a little exercise. If you want to mess around and see how things work, get this circuit diagram. A couple of things still to sort out on this Leslie 910, mainly all due to the reverb stroke tremolo circuit that is pretty much unique to this sophisticated piece of electronics, and also has to be adjusted correctly, otherwise it doesn't work. I fixed the lamp circuit, and I fixed the actual generator for the tremolo, which works off the top horn, and the sound goes through the two side speakers through its own amp. I turned off the bass and treble speakers. You've got all these 4 volume controls here, and the sound from, the instrument audio comes into this mixer here, which has sends the sound off to the 3 channels, and the amplifies the reverb and controls the reverb. I've made the control circuit here for the rotary on off, fast and slow, and also converted it for the reverb off, fully on. And now I've added a pot here in this position, which you can adjust from a low volume reverb to a sort of a higher volume, so it's in between full and off. It's quite useful. It's just a matter of wiring up a pot and some resistors inside. I've also added an LED which runs off to 28 volts, which comes in on this lead just to show that it's on. Now this stereo jack was originally part of this demo kit for the 2 channels for most Leslies, which you can use from a buffer or some sort of pedal board or the instrument through a buffer preamp. Anyway, although it's screen lead, there is a bit of pickup. Signal goes down this thick wire with the mains and everything. So to get rid of any noise, I've also added a socket plug here, mono, which is wired into the front end of the preamp, and you can turn the signal comes in from the from the jack plug on here, comes in down this wire here and plugs in there. So you can either unplug it, but easier to do. I wired this directly to the front end, and you get much less noise, any little buzzing pick-up by using that. Anyway, that's something I've done. Now, this reverb circuit doesn't work properly unless you have the bulb. There's a bulb that plugged into 2 connectors where I got those crop clips. It was a plug-in thing, same as the one I think they used in there. Without the bulb, if the bulb blows, there's nothing. The signal goes off. You get no reverb at all. If you short it out, you get a full reverb amplified, and which can cause distortion on loud signals, because the point of the bulb is, as the signal increases in level, the bulb starts conducting. It's driven through this transistor here, and the resistance of the bulb goes up, and it's like a limiter. If the bulb blows, you can put a 10 ohm resistor across there, but it runs virtually at full volume, and you get a lot of distortion on loud signals. On the circuit diagram, I found a reference saying it was a 14.4 volt battery, but it didn't tell bulb, but it didn't tell you anything about the current. So to find the right bulb, I've got the 3 bears here: low current, medium current, and high current, i.e. the resistance of the bulb
which would be the brightness, it gives you a different resistance, and I can have low, medium and high and find out which one works the best. The high current one, about 300 milliamps, this medium's 150 milliamps, and this small one's about 60 milliamps. Anyway, so that this doesn't take too long, I have tested all three. They all work. This one, the little one, compresses the sound, or limits the sound the most, and the volume of the amp is a bit too low, in my opinion. The one that takes the most current gives a fantastic loud overdriven sound, but the actual frequency sound is very bassy, and it's great for overdriven chords, but it's not very good musically. And the middle one is just right, about 150 milliamps. It's a 12 volt bulb as well, and I had it on a switch so I could work between them and adjust the volumes and everything, and it came out the best. You do have to have a bulb if you want it to sound right. Without a bulb, the reverb circuit is not sound right. If you just put a resistor in, it tends to be overload and be rather a bassy sound. So that is a critical thing. If you buy one of these and the bulb's gone, if you ever need a bulb, use a 12 volt 150 milliamp one. You will have to wire it in, because you'll never get one with the two prongs. That the original one went into the socket with two prongs, and I've never seen one of them. I don't know where that came from at all. The other channels, reverb, the other channel, the rotary horn and the lower bass, I'll do later, show you them working. The advantage of testing these channels is that you can turn these off with the volume controls, so I can turn them off and just have the side speakers and the reverb and check it out. So I'll show you it working as well. I'll turn it on, and there's a little bit of noise pickup from maybe from the guitar. You get a bit of buzzing with this open circuit and these wires like this. Down here you got, there's the reverb off. There's no reverb off, no sound. Full reverb, bit of buzzing. Medium, I can turn it up and down on the knob. Okay, the background noise, I will get rid of that. It's just a bit of pickup with all the wires and everything. I'll just try and show you what happens here, because with the guitar, now that sound is going through, and it's limited by this. It's going through the two side speakers, and I don't know if I can show. You can actually see if bulbs glowed. Let me just select the middle one. Now that's the littler one. It's much quieter. If I turn up the level, you probably might see the bulb just glowing. And that's what it's supposed to do. It limits the peaks and stops it distorting. But this one is louder, and it also limits the peaks, but you just can't see it glowing. It's too light in here to see it. Oops, sorry about the noise. It does glow a little bit, you just can't see it. Now the other one is incredibly loud. I'll turn it, and you can hear. Let me turn the guitar. Sorry, it's loud, but it's distorted. I can't, if once you start playing guitar properly, it's distorted. Anyway, just a quick thing on here as well. You can see. I can adjust the on the medium setting. Then fully on and reverb off. Now that's all quite good up to a point, but the whole thing with this reverb circuit is it's a rotary effect. I don't know how I'm going to show this and the foot pedal at the same time without confusing you, but without playing the guitar, I'm going to have to set this up on a tripod. But let me just show. I'll put this to slow speed, and it probably won't show up. Sort of pulsing, but it will show up when I put it to fast speed. Here we go. So that's the reverb. And turn it off. So the reverb is synced with the tremolo, just through the side speakers. The other speakers are no sound at the moment. So that is the control of the tremolo reverb. I'm going to wire in that bulb onto the circuit board, and then I'll just check out and demonstrate the bass and the tremolo, the rotary horn, and then them all together. Just going to try and play something through the reverb just so that you can hear the sort of effects you can get, and put it on full reverb, the simulated rotating speaker. So you can hear the depth of the reverb. Now I'll just switch it to the slow speed. So as you can hear, the reverb actually sounds a little nicer, I think, with the slow speed. But anyway, not much in it between off and the slow speed. Now I'm going to switch it to fast speed. Remember, this is just a filler sound for when the main speakers are on, just to add extra depth. So the depth amount of reverb is not adjustable, only the volume. So that's the reverb circuit for anyone's interested. A very complicated piece of circuitry. When it goes wrong, it'd be no good at all. So you've got to have the light dependent resistor working, the overload bulb working. You've got to have the variable rotating capacitor working. It's all got to work, otherwise it's useless. As far as I know, it wasn't fitted in any other lessons, and probably the reason why is because when it went wrong, it was probably no one ever fixed it.
The 910, we've got the control box here. It's just got the reverb off and no rotary at the moment, so you've got the basic sound. Now if you add some reverb, just a little bit, or we can add a full reverb. Which is a lot. Just take it off a bit. I mean, you could use that full reverb for something like with the reverb off, you got and with a bit of reverb. And with the slow rotor on. And you can have the fast rotor with some reverb. So that's all the controls available, all on this control panel here. The actual balance of the volumes on the back panel, which you set up, preset it. I've got them all on full now. And you just plug in your instrument guitar either in the back or with this cable here, which is disconnected when you're plugged in the back. And you've got the mains also cable there, so everything's ready to go.